Hello, so in today's video, we're going to look at solving inequalities in linear variables. So this is the next topic in the A-level maths syllabus. I mean, with this first one here, this looks like a standard linear inequality that you would solve in GCSE. This one down here, this question number 2, this is actually not a linear inequality because this expression there is not linear. However, it contains a linear numerator and a linear denominator. So it's linear in this variable x. So yeah, we're going to solve these two inequalities and go through how we would do that. So we'll start with the first one here. So number 1, so we want to solve, what was it again? So 2x plus 1 is less than 3 minus x. Okay, so we're going to proceed and solve that one. So yeah, that's part A of the question. So the key thing with this is just solve it like a normal linear equation in this case. So add the x to both sides, you get 3x plus 1 is less than 3. Subtract the 2 from both sides, you get 3 is less than 2. Sorry, 3x is less than 2. And then we can divide both sides by the 3, and we get x is less than 2 over 3. So our solution would actually just be that this x is a number less than 2 over 3. So that's quite a basic one. So then part B of the question, use set notation to denote the solution. Okay, so now we're going to use set notation to write this solution. So the key thing is that x can be a real number. We're told that here. So that means in a set format, the solution will be the set of x values in the real numbers. So again, to denote a set, you use curly brackets. So curly brackets just means the set of numbers within those curly brackets. So the set of x numbers which are real, such that, and this colon here just means such that. So such that x is less than 2 over 3. So this would be our set notation solution. And then the graphical interpretation for part C, so done part A, done part B. Part C's graphical interpretation. So we've got a left-hand side, obviously, we've got a right-hand side there. Let's sketch both of those graphs. So y equals 2x plus 1, y equals 3 minus x. So yeah, we've got an x-axis like this, we've got a y-axis like that. Y equals 2x plus 1, you've got a y-intercept of 1, a gradient of 2. So something roughly like that. So that's y equals 2x plus 1. Y equals 3 minus x. So this is a y-intercept of 3 this time, and a gradient of -1. So a negative gradient, but a little bit more shallow than this other one. So you have an x-intercept there of 3 because of this this -1 gradient. You have an x-intercept there of -0.5 because of this 2 gradient. So what you'll notice then, okay, so the inequality is asking us to solve 2x plus 1 is less than 3 minus x. So where is 2x plus 1? The graph y equals 2x plus 1, a lower value than this y equals 3 minus x graph. Well, the y equals 2x plus 1 graph is less than this graph in these set of x values here. So when x is in these values here, when you pick a number on the x-axis here, your graph for y equals 2x plus 1 is a lower number than this 3 minus x graph. Again, I've made a mistake here. This should be 3 minus x. Let me just write this down here, 3 minus x. So yeah, so what we notice then is that when x is less than this point of intersection, the y equals 2x plus 1 graph is less than the 3 minus x graph. And this point of intersection here, you probably guessed it, is 2 over 3. And we can see that by our solution there. And also if we put an equal sign instead of an inequality sign there, we would actually find that point of intersection to be 2 over 3. So the graphical interpretation is this. So when x is less than 2 over 3, the graph y equals 2x plus 1 is less than y equals 3 minus x, and we can see that graphically there. So that's the graphical interpretation for question 1. Let's go on to question 2 then. So 8 minus 3x over 6x plus 1 is bigger than or equal to 2. So this is question 2. So 8 minus 3x over 6x plus 1 is greater than or equal to 2. Okay, with this one here, again, this is actually not quite a linear inequality because of this non-linear term here, although it is a quotient or a fraction of two linear terms. How would we go about solving this one? So I guess the key thing with this one is to realize that when you've got inequalities, so for example, let's just say 3 over -2 is bigger than x. When you multiply both sides by a negative number, you actually change the you flip the sign over. So you get 3 is less than -2x. So we've got to be careful because x can be any number, which means that 6x plus 1 could be any number. So we've got to be careful to consider multiple cases, because 6x plus 1 could be a positive number, or it could also be a negative number. So we just got to be careful to consider all of the possible cases. So let's consider case number 1. So case number 1 is the simpler case. So this is when 6x plus 1 is positive. So 6x plus 1 is positive. So when this denominator is positive, we can just multiply both sides by that denominator without having to worry about changing this sign over. So we get 8 minus 3x is greater than or equal to 2 times by 6x plus 1. We can just expand the brackets here. So 8 minus 3x is greater than or equal to 12x plus 2. And we can just rearrange this, add the 3x to both sides, take away 2 from both sides. We get 6 is greater than or equal to 15x. And so therefore, we get 6 over 15 is greater than or equal to x. If we simplify that fraction, 6 over 15 is just the same as 2 over 5. So we're basically saying that x is less than or equal to 2 over 5. So when 6x plus 1 is bigger than 0, x is less than 2 over 5, less than or equal to 2 over 5. Now, if this is the case, however, let's just make a note of this over here. So if 6x plus 1 is bigger than 0, well, that means that 6x is bigger than 1, and that means that x is actually bigger than 1 over 6. Okay, so when x is bigger than 1 over 6, x must be less than 2 over 5. So actually in case number 1, the solution, so case 1 solution, that's going to be that x is bigger than 1 over 6. So 1 over 6 is less than x, but it's actually smaller than or equal to 2 over 5. So that would be our solution in case number 1. Again, because we want to ensure that 6x plus 1 is bigger than 0, but we get this result here that x must be less than or equal to 2 over 5. So that would be our case number 1 solution. And then our case number 2 solution. So this would be the case that, so do this here, so case number 2. So case 2 is the case that 6x plus 1 is actually now a number less than 0. So now this denominator is now negative. When you multiply both sides of an inequality by a negative number, you change the sign. You keep the equal sign there in this case, because we don't want to change the capability for the left-hand side to be equal to the right-hand side, but we do want to flip it to a less than or equal to sign instead. So we're going to get 8 minus 3x is less than or equal to 2 times by 6x plus 1. Okay, so we get that. Just if we expand the brackets again, 8 minus 3x is less than or equal to 12x plus 2. Again, rearrange this. We get 6 is less than or equal to 15x. And then just solve this. We get 6 over 15 is less than or equal to x. So therefore, x is greater than or equal to 2 over 5. Again, because 2 over 5 is the same as 6 over 15. Okay, great. So we got that. Again, we're going to do a similar thing with what we did in case number 1. Is we just need to consider what this stipulation means. So if 6x plus 1 is bigger than 0, then that actually means that 6x is less than -1. And so that means that 6x is less than -1 over 6. So when x is less than -1 over 6, it must be true that x is greater than 2 over 5. But that doesn't actually make any sense. So x isn't, so if we think about it like a number line, we've got -1 over 6 here. Let's just say that's -1 over 6. Let's just say that's 2 over 3, 2 over 5, sorry, over there. Okay, so when x is less than -1 over 6, x must be bigger than or equal to 2 over 5. I mean, that makes no sense. We've stipulated that x must be less than 1 over 6, -1 over 6, but we find out that x is greater than or equal to 2 over 5. This doesn't work. So therefore, this case 2 here doesn't give us any solution there, essentially. So we actually just ignore, we have to ignore this here, because we get kind of like a contradiction in this case. When 6x plus 1 is less than 0, we get a solution, x is being bigger than 2 over 5. That can't work. They've got to correspond. So we get no solution with that case there. Technically, we've got one more case to consider, and that's the case when the denominator actually does equal 0 itself. So case number 3. So case 3. So this is, yeah, when 6x plus 1 actually equals 0. So 6x plus 1 equals 0. So in this case, when your denominator is 0, well, this is going to be undefined. When you divide by 0, you get an undefined number. So this is actually, yeah, this inequality is undefined. So that would give us an undefined inequality. So we get no solutions from this case here. Okay, so it looks like the only solution then is literally this up here. So this x is between 1 over 6 and 2 over 5. So yeah, so our solution is going to be 1 over 6 is less than x less than or equal to 2 over 5. Because in the case that this number is bigger than 0, it has to be true that x is less than or equal to 2 over 5. And again, this case number 2 gives us inconsistent inequalities. So that's impossible, this case number 2 there, as is case number 3, because we get an undefined inequality. So that's our solution. And then going back to part B, so this time we want to write it in set notation. So to write this solution in set notation, so the solution is going to be the set of x numbers, which are, or the set of x values in the real numbers, such that x is between 1 over 6 and less than or equal to 2 over 5. So that would be our solution in set notation. And then part C, the graphical interpretation of what this means. So similarly to the first question, it just means that when x is between 1 over 6 and 2 over 5, the graph y equals 8 minus 3x over 6x plus 1 is bigger than y equals 2. So we'll just write this down here. So when, so this is part C, so when x is between 1 over 6 and 2 over 5, y equals, so the graph y equals 8 minus 3x over 6x plus 1 is greater than the graph y equals 2. So we don't actually need to know how to sketch this graph in A-level maths. This is a quotient of two linear functions. You actually don't need to know how you sketch a graph like this in A-level maths. I mean, we will be sketching reciprocal functions, but not these kind of reciprocal functions. You don't need to know specifically how to sketch a linear function, two linear functions with in a fraction. But it will look something like this. So you're going to have an asymptote x equals minus 1 over 6. Again, we've not really talked about asymptotes yet, but we'll come on to that soon. And that's because when x is equal to 1 over 6, as we can see over here, when you rearrange this, you get x equals negative 1 over 6. So when x equals negative 1 over 6, the inequality is undefined. So the graph up here is undefined. So the graph of y equals 8 minus 3x over 6x plus 1 is not defined. You also have an asymptote in this case at negative 1/2. Again, you don't really need to know why that is the case, but you do have an asymptote at negative 1 over 2. So yeah, the graph of this is going to look something like that. This it should look like. Let me just move this. I can't really do that, but yeah, it should look something like this. The line should go like that. Yeah, so we've got the line y equals 2. Again, this graph here is just to make this clear. Y equals 8 minus 3x over 6x plus 1. The graph y equals 2, something like this. So this is our y equals 2 line. So what we can see then is that we've got a point of intersection here, this point of intersection is going to be the 2/5 that we found there and there. So that's our 2/5. So what we can say then is that when x is between -1/6 and 2/5, this graph is bigger than the y equals 2 graph. So our reciprocal graph, this quotient graph, is bigger than this y equals 2 graph for these x values between, as we said, between 1/6 and 2/5 there. Because as we can see from the graph is above this y equals 2 line there. So that graph confirms our solution essentially for that. And that's the graphical interpretation done. So yeah, we've completed this question 2 here. So the key thing with these inequalities is that we can solve them. We can use set notation to denote their solution, and we can use a graphical interpretation to interpret what this means graphically. And the key thing to remember with these inequalities where you have fractions is just be careful to consider all the cases, because this denominator could be negative, it could be positive. So we just want to consider all of the possible cases and match up each case, or check if each case is consistent with the initial stipulation. So that's what we want to do always with these inequalities in linear variables.